This is a video to look at the requirements of GCSE, the water section and solubility. So we'll start off just with sort of the basics of water, its properties, the bonding, why things are soluble and what's soluble, what isn't soluble, etc. And then we'll move on to the calculations and how you actually calculate the solubility of a solute in a solvent. Some of those calculations will get fairly tricky towards the end. It'll be aimed really at A star and A grade questions. So see how you go. As long as you can do the ones at the start and you're happy enough with that, okay, have a go at the ones that come later and see how you get on. So we need to be able to understand the physical properties of water. Most of us should know that already. We should be able to draw the bonding diagram, the dot cross diagram, in other words, in water. Again, we should all know that. We just probably need to refresh over it. Okay, we will need to know how to show if a substance actually contains water. So there's some chemical tests that you have to be aware of. Again, you've actually already done them. And we will have to know several definitions that are associated with water. So there's several questions on the board now. I'd like you to stop the video and see if you can have a go at those. Okay, so if you pause the video now. So the boiling point of water, obviously 100 degrees Celsius, the melting point 0.0 degrees Celsius. Color of water, of pure water, is colorless, so don't say clear, don't say anything, it's colorless, end of. Odor, it is odorless. Formula of water is, I think there's nobody in this that wouldn't know that already, that is of course H2O. The dot cross diagram of water is a hydrogen attached to two hydrogens attached to one oxygen, like so. So that's your dot cross diagram. And can pure water conduct electricity? No, it cannot. Water will only conduct electricity when it has impurities dissolved in it. So nice, simple get-go. There's the answers to most of them there. How do we test for water? Well, we have a couple of tests that you have to know. There is cobalt chloride paper, which is just a blue color. You can see it on the screen here. If we add a liquid to it, which contains water, we get pink. And this is a substance here called hydrated now. Hydrated cobalt 2 chloride. Over here, you should probably already know this. That is called anhydrous cobalt chloride. So it goes from blue to pink. That's a test for water. The other test for water is using anhydrous copper sulfate. We've got anhydrous copper sulfate here. It is white. If we add water to it, we get what we call hydrated copper sulfate, which is what we have over here. And that is that blue color in the middle of the screen now. So those are your two tests for the presence of water. Okay, now you have several definitions that you need to source. Okay, so you'll see them in your notes and you'll see them down here. So those are all the definitions you need to know. I'm going to pop them up on the screen now. I'm not really going to talk through them, they're fairly self-explanatory. So you can pause the video if you want to write them down or learn them, or okay. And again, you can pause the video again if you want to write them down into your notes. Okay, so hopefully you can do all of those things that are on the board now. So let's look at the main section of this water topic and the most difficult section, which is just solubility. So we need to describe, first of all, a trend with regards to the solubility of solids and gases in water. We'll do that in a little second. We need to understand the implications of thermal pollution with regards to bodies of water. Okay, again, we'll do that in a minute. We need to understand the term solubility. That is a definition. It's a 4-mark definition, so make sure you learn it well. We need to select correct reagents to form a soluble or an insoluble salt. We'll do a little exercise on that later and we'll see how that goes. We need to plot and carry out calculations using solubility graphs or solubility curves. Okay, that's where the toughest questions will crop up. Right, so solubility Some substances will of course dissolve in water better than others. We should already know that. I want you to have a look at the table, and I want you to tell me what is the trend in solubility in water as temperature increases for solids and for gases. If you pause the video, have a little look at it, and then press play again and I'll explain it. It's very straightforward. Okay, so you can hopefully see that as a solid, as the temperature increases from 25 to 45, all of the solids increased in their solubility. So in other words, as you increase the temperature of water, the solubility of a solid increases. The complete opposite is true for gases. As we decrease the temperature of the water, the solubility increases, or as we increase the temperature of the water, the solubility decreases. Now, why is that important? Well, if we think about water that is used industrially to cool chemical reactors and to cool equipment within factories, that water is taken in from a body of water. And as that water is taken in, the temperature of the water will of course increases because it's being used to cool chemical reactions, okay, or chemical reaction vessels. Now, that's not to say that there's chemicals going into the water, it's just really being used to cool the water. So what happens therefore is that the temperature, the degrees Celsius of the water will increase. If the temperature increases, what happens to the amount of oxygen dissolved in the water? Well, the amount of oxygen dissolved in the water decreases. If that company was then to put that water back out again, there would be less oxygen in the water. Okay, that means that any life in the body of water cannot respire. Okay, so just like you and I need oxygen to respire, we breathe in oxygen to respire, to give us energy, to stay alive essentially. Animals within the river that we have on the board are exactly the same. So these companies need to cool the water back down again before they put it back out. They need to reoxygenate it, so bubble oxygen into it, okay, and try and restore it to the original state that it was before they took it in. Okay, so that's what we call thermal pollution, polluting a waterway by heat as opposed to actually putting any chemicals into it. So you can see on the board there, I'll just clear my annotations of it, so if you want to read what I've written there, but it's pretty much what I just said. So there's a little question for you. You can pause the video and do it, and I'll tell you the answer. Pause the video now. So this is a 5 marker, so just be careful, although there is a QWC part to it. So very simply, you need to talk here about the fact that if the water increases in temperature, the solubility of gases decreases, and in particular the solubility of oxygen will decrease in the water, therefore there'll be less oxygen for the fish, and there'll be less oxygen for the fish to use for respiration, and if fish can't undergo respiration, they will die. Right, let's look now at actually measuring the solubility of water. What actually is solubility? So there's your definition in the bold on the screen. It is the maximum mass of solute that will dissolve in 100 grams. Notice 100 grams of water, not a volume like 100 cubic centimeters. But please do remember that 100 cubic centimeters and 100 grams of water are equal. Okay, the density of water is 1 gram per cubic centimeter. So the volume and the mass of water are always the same. So it's the maximum mass of a solute that will dissolve in 100 grams of a solvent. The solvent that you'll be dealing with will be water, of course, at a particular temperature. So that's your definition. Make sure you learn it well. It's frequently worth 3 to 4 marks. It's one of the higher scoring definitions on the spec. So let's just very quickly run through a few using the solubility tables at the back of your periodic table or your data sheet. So I'll just throw out a few names. You just pause the video, have a look, decide whether they are soluble or insoluble. That's all we can tell from here. So let's say a sodium nitrate. So sodium nitrate is indeed soluble. All soluble salts are soluble, or all sodium salts are soluble, and all nitrates are soluble. So it's definitely soluble. What about ammonium carbonate? Okay, Well, all carbonates are insoluble except ammonium carbonate, so therefore it is soluble. Alternatively, it says up here, all ammonium salts are soluble. So you have two ways to work that out. What about potassium bromide? Well, let's go down to bromides. Most bromides are soluble except silver and lead bromide. Well, it also tells you up here that all potassium salts are soluble, so it is indeed soluble. What about barium sulfate? Let's go to sulfates. Most sulfates are soluble except lead and barium. Well, there you go. So therefore, barium sulfate is not soluble. What about copper carbonate? Insoluble. Most carbonates are insoluble except sodium, potassium, and ammonium. So copper carbonate must be therefore insoluble. What about zinc hydroxide? Well, insoluble. Most hydroxides are insoluble except sodium, potassium, ammonium, so zinc hydroxide must be insoluble. What about, let's say, iron oxide? Iron oxide, most oxides are insoluble except sodium, potassium, calcium. Okay, so therefore iron oxide must be insoluble. Okay, what about silver bromide? Let's go up here. Most bromides are soluble this time. Okay, except silver and lead, bromide, chloride, iodide. Well, there you go, there's silver bromide that I asked you about, so silver bromide is insoluble. Hopefully you can use that. Simple little questions. So remember your definition for solubility. It is the mass of solute that will dissolve in 100 grams or 100 cubic centimeters of water at a particular temperature. And the question here asks very simply, what therefore would the solubility of sodium chloride, based on the information in the question, what would the solubility of sodium chloride be? So we've said there's 7.2 grams that will dissolve in 20 cubic centimeters. Essentially what we're asking is, well, how many grams will dissolve in 100 grams of water or 100 cubic centimeters? Well, if 7.2 dissolve in 20 grams or 20 cubic centimeters, well then 5 times that will dissolve in 100, because there's obviously 5 20s in 100, so the answer would be 36 grams of sodium chloride will dissolve at 25 degrees Celsius in 100 grams of water. So the solubility would be expressed as 36 grams per 100 grams of water. Sorry, I think I said 36 grams. Okay? Right. What happens then, okay, if we take 100 grams of water, which contains 36 grams of sodium chloride, in other words, it's saturated, okay, and we cool that from 25 grams down to 10. Well, we said earlier that as you decrease the temperature of a body of water, the solubility of solids decreases. So therefore, if we go from 25 degrees Celsius down to 10 degrees Celsius, 36 grams can no longer dissolve. It has to be less than 36 grams of that will dissolve. Okay, so what would you see is what all the examiner asks you here. Well, what you'll see is you'll see some solid residues, some solid crystals appear at the bottom of this beaker. Okay, so you'll see solid crystallizing out. Now your job in these later questions will be to calculate exactly what mass of that solid that would crystallize out. So this is where our solubility curves or solubility graphs come into play. So we're going to start off with some very simple questions. We'll kind of build these up into more difficult ones as we go along. So which solid, so maybe a good idea if you pause the video every time I bring up a question, and then I'll go straight into the explanation. So as soon as the question comes up, I'd suggest you pause it, then I will explain. Okay. You can just hit play again. Which solid is most soluble at 30 degrees? Well, that's pretty simple. We go to 30 degrees. We go straight up at 30 degrees. We see that the most soluble one is sodium nitrate. It has 80 grams dissolving in 100 grams of water at 30 degrees. So our answer there is, of course, NaNO3 or sodium nitrate. Which solid solubility is least affected by temperature? Well, you can see the brown line here for sodium chloride. The temperature changes and the solubility of sodium chloride changes very, very little. So the answer is sodium chloride. At what temperature is the solubility of potassium nitrate and sodium nitrate the same? Well, if we take the red line and the purple line, okay, which are those two compounds that we're talking about, we can see that they overlap. They have exactly the same solubility here at 70 degrees. So the solubility is there. It's about 130 grams per 100 grams, but either way, it's the same at 70 degrees Celsius. What temperature does water need to be to saturate 100 grams of it with 80 grams of sodium nitrate? Well, let's go. So we've got 80 grams of sodium nitrate, 80 grams per 100 grams is here. Okay, and I'm going to use my red line, my sodium nitrate line. Always be sure to use the right line. So if I go across and down from 80 down, it's 20 degrees Celsius. So at 20 degrees Celsius, 80 grams of sodium nitrate will dissolve in 100 grams of water to saturate. You cannot get any more to dissolve. So the answer is 20 degrees Celsius. Those are all pretty simple, straightforward introductory questions. We'll start cranking it up now, making things a little bit trickier. So this time, at what temperature does the water need to be to saturate 25 grams of water with 40 grams of potassium nitrate? So our graph is per 100 grams of water, but we've been asked for 25 grams of water. Now here's what I would do here. I would take my 25 grams of water, obviously we're working on the graph in 100, okay, and at 25 grams of water, we would saturate 40, go to 40 grams of potassium nitrate, scale that up to the 100, that brings that times by 4, of course. So really what they're asking us here, okay, is at what temperature does 160 grams of potassium nitrate saturate the 100 grams of water? So we go to 160 here, we go across and we go down. Make sure we pick the right line, it's the purple line this time. So we go across to here, we go down to here. So at 80 degrees Celsius, 160 grams of potassium nitrate will saturate the 100 grams of water. Or in other words, if we only had 25 grams of water, it would be 40 grams of potassium nitrate that would saturate it. So in other words, the answer is 80 degrees Celsius. Again, pause the video on this one. So we have a saturated solution of potassium nitrate and 100 grams of water. So that's good, that's what our graph is in, okay? And that was cooled from 80 degrees Celsius down to 40 degrees Celsius, and we've got to now this time work out what mass of solid crystallizes out at the bottom. So let's go and find our correct line. So this time we're using the purple line again. We're starting at 80 degrees Celsius. So at 80 degrees Celsius, we know at 80 degrees Celsius 160 grams of the solid will dissolve, because if we go up and we go across, that's what we get. We're going to cool it down to 40. So again, we'll go 40 degrees Celsius, we go to the purple line, we go across, that brings us across to 60. So at 80 degrees Celsius, we're able to dissolve 160 grams. At 40 degrees Celsius, we could only dissolve 60 grams. So there must be 100 grams of that solid that's going to crystallize out at the bottom. Okay, just clear that. So, a saturated solution of sodium nitrate this time. Okay, so we're going to use again a different solid. Okay, so saturated solution of sodium nitrate. So again, we're using the red line this time, so just be careful. Now this time we've gone for 20 grams of water. Okay, so again, be careful. All right, so that is going to be 1/5 of the water that we have on our graph. And it was cooled from 90 down to 20, what mass crystallizes out. So we're going to go to 90 degrees and we're going to go to our sodium nitrate, isn't it? Sodium nitrate, and we're going to go to there. So that's at 90 degrees, we have 160 grams will dissolve in the water, and we're going to cool that down to 20 degrees. So down to here, sodium nitrate, red line. Okay, so at 20 degrees, 80 grams will dissolve. So therefore, in total, 80 grams will crystallize out. Originally, 160 would dissolve, then only 80 would dissolve, so 80 is going to crystallize out. Now, but remember, we have 80 crystallizing out, but that's only in 20 grams of water. Our graph is representative of 100 grams of water, so we need to take that and divide it by 5, okay? I think 80 divided by 5 is 16 grams would crystallize out. Right, let's look at some more. We're going to get a little bit more difficult now. So on cooling a solution of potassium nitrate containing 20, so again, let's highlight what's key here. Only 25 grams of water. We're going from 90, okay? And as we cooled it, 35 grams of the solid crystallized out. We've now got to calculate what is the new temperature. So this is again a bit of a variation on the questions that we've been doing so far. So let's have a look. This is 25 grams of water and 35 grams crystallizes out. So the first thing that I would do is I would adjust this from the 25 grams of water. I would adjust it to the 100 grams of water. So if this was 100 grams of water, we would have 35 times 4, 140 grams would crystallize out. So again, we're taking the purple line, so just make sure you take the purple line. We're starting at 90 degrees Celsius. So at the purple line at 90 degrees Celsius, if we go up and go across, there is 200 grams of water that would dissolve. So we're starting off with 200 grams saturated. We're going to cool this down, okay, and we're going to cool, when we cool it down, we're going to get 140 grams crystallizing out. Okay, so if 140 grams crystallizes out, that means that only 60 grams can actually dissolve in the solution at the minute. So if we go down, making sure we're still sticking with our purple line to where 60 grams does dissolve, we go across and we go down, we'll find that it's at 40 degrees Celsius that 60 grams of this will still be in solution. So in other words, 140 will have crystallized out. So the answer to that is 40. Well done if you got that. We're starting to get into the hard ones now. Okay, let's look at this one. So this time we have a solution of sodium nitrate. All right, so we're going red line, remember? Okay, so red line. And 12.5 grams of water. Now, remember, that is an eighth of the 100 grams that we have on the board. Okay, and that water was cooled from 100 to a lower temperature, and 12.5 grams of solid crystallized out. Okay, so let's have a look. So we've got, start off with 100 grams. We've got to go right over to the very edge here, and at 100 grams, if I go up to my red line and I go across, I can see at 100 degrees Celsius, sorry, we can dissolve 180 grams of that solid. We've got 12.5 grams came out whenever it was 12.5 grams of water. Bit confusing that. Okay, that means that 100 grams of the solid would crystallize out if there was 100 grams of water. So let's take away from that 100 grams. So that means we've got to go to where 80 grams of this solid would actually dissolve. So again, stick to your correct line. It's the sodium nitrate, it's the red line. So we go 80. And we go down. The temperature here is 20 degrees Celsius. So we started at 100. We had to cool it down to 20. Now be careful and don't answer this question like the last one. This question asks, how many degrees Celsius was the solution cooled by? A lot of people will write the answer of 20 degrees Celsius, but it was actually cooled from 100 down to 20. So the answer is actually, it's been reduced by 80 degrees Celsius. Okay, let's have a look at this one. Solution of potassium nitrate this time, so that's our purple line, and 40 grams of water. So again, 40 grams is 2.5 times 40 brings us up to our 100 grams of water. Okay, 40 grams of water, and that contains 60 grams of solid. Okay, so at 90 degrees Celsius, let's write out what we've got here. 90 degrees Celsius, okay, and 40 grams of water, okay, we had 60 grams of the potassium nitrate. Now that means in 100 grams of water, that is equivalent to 60 multiplied by 2.5, 150 if my mental arithmetic is correct. Okay, so that's equivalent to 150 grams of, now let's go, we're going to 90 degrees Celsius. We are dealing with the purple line, And we will notice now the purple line, you can actually dissolve 200 grams of the solid at 90 degrees Celsius. But in actual fact, in our question this time, and this is new, there's only 150 grams of the solid in there, so we need to be very careful. So in actual fact, let's say we are actually only dissolving here, or we only have dissolved 150 grams. So this is an unsaturated solution that we are starting off with. It then says we cool this down to 20 degrees Celsius. Okay, so at 20 degrees Celsius, with our purple line, we can dissolve 30 grams of the solid. And it asks us what mass of solid crystallizes out. So what mass of solid crystallizes out? A lot of people will go 200 minus the 30 down here, and they'll get an answer of 170 degrees, or sorry, 200 minus the 30 divided by 2.5. I'm not sure what that is. That will be the wrong answer. The right answer has to be the 150 minus the 30, but remember that's per 100 grams of water. In our question, we're only working in 40 grams of water, so we need to take that, whatever it is, and divide it, well, it's 120, and divide it by 2.5. So the answer comes out at 48 grams of the solid would dissolve out. Okay, hope that makes some sense to you. Right, let's have a look then at, let's have a look then at the next one. Okay, so this time we've got 25 grams of water. So again, let's just remind ourselves that this time we're working in a quarter of what is on the graph. Was heated to 60 degrees Celsius and 80 grams of sodium nitrate. So sodium nitrate, we're working on the red line. Okay, it was added, the solution was cooled to 20. What mass of solid was found at the bottom of the container? Right, so if I have 25 grams of water, okay, so at 60 degrees Celsius, I have 25 grams of water, and I have in that 80 grams of sodium nitrate. That means in 100 grams of water, I would have 4 times that, which is 320 grams of sodium nitrate. And we're at 60 degrees Celsius. So let's go to the 60 degrees Celsius. Let's go up to the sodium nitrate. Okay, we are here. Now, what I will notice at that temperature, I can only dissolve 120 grams of sodium nitrate. I've actually got equivalent to 320 grams dissolved in sodium nitrate dissolved in the water. So this substance already has some solid lying at the bottom of the beaker because some is already crystallized out. The question is, what mass of solid was found at the bottom of the beaker? Well, we've already got 200 grams lying at the bottom of the beaker. Okay, now we're going to cool this down to 20 degrees Celsius. Okay, so let's cool it down to 20 degrees Celsius, and we are on the red line. Yeah, we're on the red line. Okay, so at 20 degrees Celsius, you will be able to dissolve 80. So at the start, I had 320, okay, equal to 320. I'm going to cool it down to 20 degrees Celsius. Now I can only dissolve 80, so I'm going to have 240 grams lying at the bottom of this beaker. Okay, now, but remember, it's only in 25 grams of water, whereas the 240 would be in 100 grams of water. So I'm going to take that and I'm going to divide it by 4. So at the bottom of the beaker, after all of that, I'm going to have 60 grams of solid. So well done if you got that one. That's a tricky one. That's how you did. Okay, next one. There's not many left. We're getting to these are the really difficult ones now. 50 grams of water was heated to 90 degrees Celsius and 85 grams of potassium nitrate was added. Was the solution saturated? So all we're after here is very simple, yes or no. So we had 50 grams of water. Well, let's scale it up to 100 grams of water. So 100 grams of water, that would be 85 times 2, which would be 170 grams of potassium nitrate would be in there. So we go to 90 degrees Celsius and we go up from 90, okay, we will see that the potassium nitrate, or purple line, okay, you can dissolve 200 grams of potassium nitrate in 100 grams of water at 90 degrees Celsius. So therefore, we've only equivalently added 170 grams in our question. So that is an unsaturated solution. We could add another 30 grams to it. So no is the simple answer. What mass of solid needs to be added to the solution to saturate? Well, it was 30 grams. I just showed you that. Oh, sorry, it wasn't 30 grams. 15 grams. My mistake. The question was at 50 grams of water. Okay, the 30 grams was if it was 100 grams of water. Okay, 50 grams of water was heated to 90 degrees Celsius. 75 grams of potassium nitrate is added. The solution was then cooled, so let's just adjust. We'll go to 100 grams of water. Okay, and we'll say that that's equivalent to 150 grams of potassium nitrate being added. Okay, and we'll remind ourselves that we're at 90 degrees Celsius. Okay, the solution was then cooled to 0 degrees Celsius. Okay, so that's a lot of cooling. 0 degrees Celsius. What mass of solid would crystallize out? So let's have a look here. We are working on the purple line, and on the purple line we're going down to 0. That is about 10 grams as far as I can see there. Okay. So we had, let's just check now first of all that we're not oversaturated here. So we were at 90 degrees Celsius, yep. Okay, and that would allow 200 to dissolve. We'd only got 150 dissolved, so just be careful. It's not a saturated solution that we're starting off with. Okay, we would have 150 there. We would be able to dissolve 10 at that temperature. Okay. So when we dissolve that out, when we cool that down, we get 140 grams dissolving out. But remember, that's in 100 grams of water. The question is only per 50 grams of water, so it's 140 grams here divided by 2. So the answer would be 70 grams. Okay. Last couple. Right, 20 grams of solid was deposited on the cooling of a solution of potassium nitrate in 50 grams of water from 60. What temperature was the solution cooled? Well, we've actually sort of done one very similar to this already. Anyway, let's have a look. So we have 20 grams of the solid was deposited, a solution of potassium. Right, so we've got 50 grams of water. We are at 60 degrees Celsius. And we have deposited 20 grams. Okay, so that is as if we had 100 grams of the water. Okay, and we're cooling from 60 degrees Celsius, and 40 grams was deposited. So let's go and find, we're working on the purple line. Okay, we're starting at 60, we're going to purple line, purple line, purple line. Brings us up to here, that is 100 grams. Okay, if we were to cool that to 60, we would deposit 40, so we're taking away our 40, so we're going down to 60 grams. So here's our 60 grams here, we go across to there, yeah. Okay, that is 40 degrees Celsius. What temperature was the solution cooled to? Well, the solution was cooled to 40 degrees Celsius. Chemist has 500 grams of solution, so we're ranking up the volume of solution here. 500 grams of solution of sodium nitrate. Okay, so let's again adjust this. So let's scale it to 100 grams of water. And we are at 50 degrees Celsius. Okay, they want to collect 200 grams of the solid. All right, so if we were collecting, we would want to collect a fifth of that, which is 40 grams we would have to collect, okay, instead of 200, because obviously this is 5 times that. What temperature does the solution need to be cooled out to? Okay, so we are sodium nitrate, so a red line, we're at 50 degrees Celsius. Okay, so we are here, a bit of an awkward number. So what's that? That's about 105, I think, give or take 1 or 2 grams, yeah. So we're about 105, okay, they want to collect 40, so they're going to have to cool that down to, what's that, 65, where we're able to get 65 dissolved. So let's go to 65 in our graph. 65 is, what have we got there? Well, 65 has to be about there, doesn't it? Looks like it has to be cooled right down to 0 degrees Celsius. Okay, yep, exactly. So 65, we've got to go right the whole way down to 0, because that's 65 is at the 0 point, and our answer is 0 degrees Celsius. We'd have to cool that the whole way down to 0. Okay guys, I hope that helps. There's a lot of good questions in there, a lot of straightforward ones, but also a lot of really difficult ones. If you can do those, you will be able to do any solubility question that is thrown at you, any solubility calculation that's thrown at you at GCSE. So I hope that helped. You have lots of past paper questions at the end of your notes and in your booklets.